Hi guys, so I wanted to go through something real quick. I know we talked about the other day of if we have an object, right, and we have, potential energy up here due to gravity, and then we have kinetic energy down here when it's moving, right? And if we have friction along our path, we talked about the idea that there's work that's being done, and so these energies then are not equal. And you guys had talked about, well, work is force times displacement cosine theta. And what I was thinking about after class was, if you always put it in a way of work is before my equal sign, and take into account EG plus force distance cosine theta equals EK. In this case, as it's sliding, my frictional force is going to be backwards, my displacement would be forward, so that would make this a negative, right? And really, that's going to be fine and result in the fact that this value is going to be smaller than this value because we're subtracting the work that's done, right? If this, for some reason, was a force pushing in the positive direction, and that would be a positive work, that would make this a positive, and then that would still produce the result that we want with EK being bigger than EG. So if you want to be consistent, I would always put the work in front of my equal sign, always make it a plus, and then using the equation for work, that's going to make it a positive or a negative, right? So based upon how the angle is between my force and my displacement, that'll tell us if it's going to add energy into the system by being a positive, or if it's going to subtract energy from the system by being a negative. So just to be consistent, I would say, make sure it's initial energy situation plus the work done externally is going to equal the final. So just a more broad setup, it would be energy plus the work equals energy. And so as long as we set it up in this format, if I have no energy initial, it would just be work equals now my final energy. But this is going to be the best setup that you could have. And in this way, as long as we put work in front of my equation or in front of my equal sign, it's going to account for how that theta is acting. So hopefully that clears some of that up. I wanted to just go through this question here and just kind of show you how you might set this up. And then you guys are going to work through this as well. So the idea is we have a 100 Newton box. It's initially at rest on a rough horizontal surface where the coefficient of static friction is 0.6 and the coefficient of kinetic friction is 0.4. Student decides to move the box by applying a horizontal force of 80 newtons to the box to the right as shown, so 80 newtons. The box starts at rest at point A. Fill in the work kinetic energy bar chart for the box as it moves between points A and B. The chart at left below columns for work done by 4 kinds of external forces. In the summary, then you're going to do the net work. So I'm going to label my forces, in that we have the force of gravity down, that's going to be 100. We have our normal force up, that's also going to be 100 because those two are going to be equal. We have our pull force to the right, and then we have a frictional force to the left. And really, once it gets moving, that's going to be the kinetic friction that is acting. So my force of friction is going to be my coefficient of friction times the normal force, which that is going to be 0.4 times 100, or just 40. So here's what we have to think about. How would we fill in this chart? Work energy bar chart. Initial energy of our system. It says it's initially at rest, so our initial kinetic energy is simply 0. Then we can go through the work done by gravity, by spring, by friction, and then by the applied force, right? So it's going to pull it a distance of 5 meters. So the work done by gravity is going to be 100 times 5 times the cosine of 90, which that is 0, and so the work done by gravity is 0. Work done by the spring, there is no spring, so that is simply 0 as well. The work done by friction. All right, well, we're going to take as the force of friction as 40. So the force is 40. It applies for 5 meters, and then that's the cosine of 180. So that's -1. And so that's going to be a value of -200 Newton meters. And then, so let's just do, we'll do 50. So 50, 100, 150, 200. So every box represents 50 for us. And then the work done by the applied is going to be 80 times 5 times the cosine of 0. And in this case, my cosine of 0 would be 1, and so that is 400. So 200 is 4 blocks, 400, so 50, 100, 50, 100. So that's the work done by the applied. And so the kinetic energy final is simply going to be 200. Okay, looking at my summary chart, essentially we have 0 here. We have 200 as my net, because we have positive 400 and negative 200. So the net is going to be a positive 200. And so the work, or the energy at the end, is going to be 200 as well. Lastly, this says determine your reasoning or explain your reasoning, which we just went through, and then determine the final velocity of the block. So what we know is we know our energy initial plus the work done net equals our energy final. Our energy initial is 0. The work done we know is 200 net Newton meters or joules, and that's going to equal my energy kinetic final. Kinetic energy is 1/2 mv squared, so this is going to be 200 equals 1/2 mv squared. I'm going to solve for v first, so I'm going to multiply each side by 2. It's going to get rid of my 1/2, and I get 400 equals mv squared. I'm then going to divide by m on both sides, and I get velocity equals 400 divided by mass square root. In this case, my mass is a 10. Remember, force of gravity is mass times gravity. Gravity itself is 10, so my mass must be 10 as well. So looking at this then, my velocity would be just the square root of 400 divided by 10, or the square root of 40. That's going to give me a value of roughly 6.3 meters per second. Right, and so that's the setup, and again, with this, if we put our work initial before the equation sign, then we're going to be able to account for that cosine of theta as it applies, right? So hopefully that makes sense, and hopefully that can help you guys as you're working through some of the other questions you're going to go through for today.